Okay, today we will discuss about another semiconductor device which is widely used in the applications. First one is a chopper. Okay, what do you mean by a chopper? A chopper is actually a DC equivalent of a transformer. It converts DC to DC. Okay. In the case of an AC, if we consider there is a transformer, there is a device called transformer which converts an AC to a different AC form with a different frequency. With the same frequency and a different power. So, in the similar way, in the case of DC systems, in order to convert a fixed DC to a variable DC, we use choppers. Okay, chopper systems. It offers a smooth control, high efficiency, fast response, and a regeneration. And mostly the power semiconductor devices which are used as chopper circuits are generally power BJT, power MOSFET, JTU, or force commutated thyristors. So now we will discuss about the different chopper applications or operations. Basically, there are two types of choppers. They are step up chopper and a step down chopper. So the figure here shows a step down chopper. So generally, a chopper is a high-speed on or off semiconductor switch. So in the figure, if you can see, there is a voltage source V is connected on the left-hand side of the circuit, and is connected to a load. Okay. So in the circuit also you can see a switch is placed, which is called the chopper as represented there, and there is an inductor and there is a freewheeling diode connected parallelly. So this is a simple circuit of a step down chopper. Okay. So here a fixed DC or constant DC supply of magnitude Vs is provided to the circuit, and the chopper is represented by a switch in the dotted rectangular as shown in the figure. It can be made on and off as required or as desired. Okay, the figure, the waveform shows the different output voltage or load voltage that we obtain when the switch is on and when the switch is off. If you can see, the total V0 represents the voltage across the load and I0 represents the load current. If you can see, there are two time periods represented, T on and T off. During the T on, or that is when the chopper is on or when the switch is on, the load voltage, as you can see, when the switch is on, the load voltage is equal to the source voltage Vs. Okay, now during the turn off time, what happens? When the switch is turned off, the load current flows through the freewheeling diode FT, which is connected parallelly as shown in the figure. And as a result, what happens? The load terminals are short circuited by the freewheeling diodes, and the load voltage is therefore 0 during the turn off time. So this turn on and turn off time together constitutes the total time period of the chopper, and which is called the chopping period, or chopping period capital T is equal to T on plus T off. Now what is the average output voltage? Average output voltage equation is V0 is equal to T on divided by T on plus T off into Vs, or T on by capital T into Vs. And this term T on by T is called duty cycle or capital D of the chopper. So in other words, we can say output voltage or average output voltage V0 is equal to capital D into Vs. So we can infer from this equation that as by varying the duty cycle capital D, or where capital D is T on by T, we can control the magnitude of the output voltage, that is V0 is equal to capital D into Vs. So in this circuit you can see the output voltage is always less than the input supply voltage Vs. So this is called a step down chopper. Now the next circuit shown here, it represents the step up chopper. The components are same as that of the upper circuit, but there is a small change in the alignment. If you can see, there is a voltage source of constant magnitude Vs provided as input voltage, and there is a load connected, and the voltage across the load is V0 and current through the load is I0. Okay, the switch is connected as shown in the figure. Here a large inductor capital L is connected in series with the source voltage. So what happens when the switch is on and when the switch is off? First we take the case The first figure shown here shows the how the circuit operates when the switch is on. When the switch or chopper is on, what happens is the inductor stores energy during the turn on period. The current flow is as shown in the figure through V from Vs through capital L, so through the switch and back to Vs. This is a current flow during the turn on time, or during this period the inductor stores energy. Now what happens when the chopper is switched off? So when the chopper is switched off, the current flow is as shown in the figure. As you can already seen, the inductor has stored some sort of energy during the turn on period or when the switch is turned on. So when the switch is turned off, this stored energy in the inductor, what happens? It forward biases the diode and the conduction proceeds through the load for the time period T off. So this is a current flow as shown in the figure from the inductance through the diode, through the load and back to the source. So what is the total voltage across a load during this period V0? So at that time V0 is equal to Vs plus L into di by dt. So what happens here is you can see V0 is always greater than Vs because the inductor stored energy is also released to the load. Hence we can say this circuit acts as a step up chopper, or the output voltage is greater than the input voltage. Now let us see what is the load voltage at the time of turn on and turn off period. At the time of turn on, what is the inductor's voltage? VL. So at that time the inductance voltage is, as you can see from the first figure, it is capital D into Vs, or duty cycle into Vs. So what is the voltage across the inductance during the off period? So as from the figure we can infer that it is VL is equal to V0 minus Vs. So you can see the energy stored is equal to the energy released in the inductor. So what is the energy stored when the switch is turned on? The energy stored in the inductor is Vs into T on. So what is the energy released? Voltage across it into time period V0 minus Vs into T off. So if you rearrange it, we can say V0 is equal to T on plus T off by T off into Vs, or capital T by T off into Vs. So instead of T off we can write it as T minus T on. So by rearranging we can say, but we know that T on by capital T is capital D duty cycle. So if we rearrange it, we will get the output as V0 is equal to 1 by 1 minus T into Vs. So this is the output voltage of a step down chopper. Sorry, step up chopper. So in this, from this equation we can infer that the output voltage V0 is always greater than the input voltage Vs. So usually this step up chopper is usually employed for regenerative braking of the DC motors.